friends, Recon Civil Academy has introduced a new series which is known as Video on Demand. In this, you can ask us to prepare the video on a particular chapter of your choice, either in Hindi or English. We will prepare the video exclusive for you. So if you have any query regarding this, you can contact me on this WhatsApp number. Hello friends, and let us discuss a new chapter, influence line. So till now what we have done, for a beam, let us say this is a loading, so we have find the reaction 1 meter, 2 meter and 3 meter, and we have to find the shear force bending moment at a different section. How to find reaction and how to draw SFD BMD, please see my previous video. Now in the influence line we do exactly opposite of this. So what is opposite of this? I will be having a beam without any loading. First thing is, I will be having no load on the beam. Now I will place 1 kilonewton load outside the beam, and then I will travel this load of 1 kilonewton load on this beam. So it will be having here, 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 here and so on, like this. So this 1 kilonewton load is traveling along the span of the beam, and what I will do, I will find the reaction RA for the different location of the 1 kilonewton load. So at different locations, what is the RA, what is the RB, and similarly finding the bending moment at any section when this load is moving, and finding the shear force at any section when this load is moving. So now what is the case? The case is the load is moving and the section is constant. What is happening in the previous case? The load is fixed and our section is moving. Means here I am finding the shear force and other things. But now my load will move and the section will be constant. So whatever we get when the load is moving is known as influence line. Like if load is moving like this way and I find RA, then I will say this is the influence line for RA. Similarly, if I find bending moment at any section X, then I will say it is influence line for bending moment at X and so on. I will make you understand this thing by a very simple example. Let us take a beam of 6 meter span and a load of 1 kilonewton is moving from left to right. We want to find the influence line for RA and RB. So what we will see, that when the 1 kilonewton load is here, RA is 0 and RB is also 0. Now let us take a second case. When 1 kilonewton load is at A point. So what I get? RA is equal to 1 and RB is equal to 0. Now let us take another case. When 1 kilonewton load is at a distance of X from RA, so what will be the distance from B? It will be 6 minus X. Then what is RA? You see my previous video, I have tell you a very simple concept. What is RA? 1 into 6 minus X by 6. And what is RB? RB is 1 into x by 6. So if you now compare RA and RB, then what you see? The variation of RA and RB is triangular. When x is equal to 0, RA is equal to 1 and RB is equal to 0, same as above. When x is equal to 6, which means this point, RA is 0 and RB is 1. Let us take one example when x is equal to 3, means when the load is at the center of the span. RA will be how much? It will be 6 minus 3 by 6, so it is half. And what will be RB? RB is 1 into 3 by 6, again half. When x is equal to 4, what is the value of RA? RA value is 6 minus 4 by 6. And what is the value of RB? RB is 1 into 4 by 6. So this way I understand that as x increases, RA decreases. And in this case, as x increases, RB increases. So what is the influence line now? You can see, so this is the influence line for RA and this is the influence line for RB. How I draw? I draw by this equation. By this equation, you can draw this one, and by this equation, you can draw this one. So these are the two influence line of RA and RB. I again repeat what I have done till now. So what we have done? We have put a 1 kilonewton load at any distance x and find RA and RB. The value of RA is 6 minus x by 6 and RB is x by 6. Now we plot graph of RA as x by 6. So when x is equal to 0, RB is equal to 0. When x is equal to 6, RB is equal to 1. And in between at any distance x, what will be RB? It is x by L, which is 6 here. L is our 6, so it is x by 6. Now if you see the influence line of RA, what you will get? At x equal to 0, RA is 1. At x equal to 6, RA is 0. And in between that, the variation is linear, which is 6 minus x by 6. So by this, I can say that this is the influence line of RA and this is influence line of RB. Now let us see few more questions. Now it says, what will be the maximum value of reaction RA when 10 kilonewton load passes? So my first question is, instead of 1 kilonewton, the load is 10 kilonewton. So what will be the maximum value of RA? Maximum value of RA will be when the load is here. So what I have to do? I have to multiply this value by 10. So what is the maximum value of RA? It will be 10 kilonewton, and when it will happen? When the load is at A. Now take the second case. When will be the maximum value of RB? Maximum value of the RB will be again 10, 1 multiplied by 10. And when this will happen? When the load is at RB. So RB have its maximum value when 10 kilonewton load is at B point. RA will have its maximum value when the 10 kilonewton load is at A point. So what we have to do? We have to multiply the ordinate for the one unit into the value by which the load is passing. So the simple rule. So 10 kilonewton, it will be multiplied by 10. If it is 20, then I will multiply by 20. If it is 0.5, then I multiply it by 0.5. So simple, we can find the maximum value of RA and RB and condition also when this will happen. Both things we can find by influence line. Now let us take the second problem. Now it says 2 point loads are moving. One is 10 kilonewton and another is 5 kilonewton and is spaced 2 meter apart from left to right. So two loads are passing. This is 5 kilonewton and this is 10 kilonewton. And I have to find the maximum value of RA when they are moving from left to right. So they are moving in this direction. So what will be the case? So when we will have maximum value of RA, when 10 kilonewton load is at the support and 5 kilonewton load is at 2 meter away. So this is the condition of maximum RA. Now what is the value of RA under this condition? You can solve by two methods. First find the reaction for this, or you can use the influence line also. How? This value 1 is multiplied by 10 and at 2 meter, what will be the value of this ordinate? Put x equal to 2, so it will be 4 by 6. So 4 by 6 multiplied by 5. So what is the maximum value of RA? RA maximum value will be 10 into 1 plus 5 into 4 by 6, which comes out to be 13.33. So when this pattern of loading will move on this beam, RA will experience maximum value of 13.33 kilonewton under this condition. Now let us take the second case. Now let us take it for RB. For RB, they are moving. So when will be the maximum RB? When 5 kilonewton is at this point and 10 kilonewton is at this point, and this is 2 meter away. If I put 10 kilonewton here, then what will happen? 5 kilonewton will be out of the span and that will not produce the maximum RA. So the maximum RA will be when this ordinate and this ordinate. Okay, so what is this distance? This distance is 4. So what is this ordinate now? It will be 4 by 6 and this will be 1. So multiply it by 10 and multiply this by 5. So what is the maximum value of RB? RB is 4 by 6 into 10 plus 5. So this gives you 11.66 here. So if you see again, RB will be experience maximum reaction when 5 kilonewton is at the RB and 10 kilonewton is 2 meter away. So this is the maximum condition to get RB, and the value, for value you just simply put the value, put this point, transfer these point on the influence line and multiply by the respective load, you will get the value. Now come to the third problem. Now what is the third problem? A UDL longer than 6 meter and intensity 10 kilonewton meter passes from left to right. So what it says? This is my beam without any load. Now there is a UDL of intensity 10 kilonewton meter and its span is greater than 6 meter. Then I have to find under what condition RA will be maximum and RB will be maximum. So what I have to do? Since the span is longer than the span of the beam, so it will completely occupy the loading. Okay, so this is my loading. And what is the value of RA? For RA value, what you have to do? You have to find the area under the UDL. So what will be the area? This complete area, because UDL is on the complete span. So this area multiply by the intensity of the UDL. So what is the value of RA now? RA will be 10 into half into 1 into 6. What is half into 1 into 6? Area of this triangle. And what is 10? 10 is the intensity of this UDL. So what we get? We get 30 kilonewton meter. Now what will be the value of RB? The RB value is again simple. What we will do? We will find the area under the UDL. So what is the area? Area is complete. Now what will be RB? 10 intensity into half into 1 into 6. What is this? This is the area. Again you will see 30. If you do not want to solve like this, then you can take it static problem and solve it. But I will not suggest that, because in the further question we will need this in more detail. So it is better that you apply this method only. Now what will be the case if I do not take the complete UDL? Then what will happen? Then I have only this much area multiply by 10, and that will be not the maximum RA. Did you get it? Because the load on the span is up to only this part. This load has already left the span, so it will not contribute into the RB. So this value will be less. So whenever I have UDL longer than span, then I will occupy it to the full length. What it means? It means that the area should be maximum. By UDL, the maximum area should be covered. So for that condition, we have to put the UDL on the entire beam. Now let us take this problem. A UDL of 4 meter span and intensity 10 kilonewton passes from left to right. So in this, what is happening? A UDL is smaller than the span. The UDL is of 4 and the span is 6. So what will happen? For finding RA, what I have to do? I have to occupy the maximum area under this influence line. So this area multiply by 10 will give me the maximum value of RA. So how to find this value? This is a trapezoid. This is 1. Now what will be the value of this? I can know that this is, so it will be 6 minus 4 by 6, which is 2 by 6. So what is the maximum value of RA? RA maximum is 10 into 1 plus 2 by 6 into 4 by 2. Okay, so what is this? 10 is what? 10 is the intensity of the loading. 1 is this ordinate. 2 by 6 is this ordinate. 4 is the length of this trapezoid, and by area it will be half. So how much I will get? I will get 26.66 kilonewton as RA. Now what I will do for RB? To find the maximum area, I will place the load in this fashion. For RB, the load will be like this, covering the maximum area beneath it. So this is 2 meter, this total length is 6, and this is 4. So this is 1 and what this ordinate will be? It will be 2 by 6, and this length is 4. You can see in this also. So this is 1, this is 2 by 6. So what is the value of RB? RB will be 10 into area. So what is the area? 1 plus 2 by 6 into 4 by. So that will be the value of RB. Now let us take the third problem, last problem. What is that? The last problem is two UDL are moving, one of span 2 meter and intensity 10, and one is of span 1 meter and intensity 5, and the clear spacing between them is 1 meter, passes from left to right with 5 kilonewton meter ahead. So what it means? If you see, this is the one, 5 kilonewton per meter of 1 meter and 10 kilonewton per meter of 2 meter, and this is ahead, and the distance is 1 meter. So what I have to find? I have to find the maximum value of RA. So what will be the position? This will be the position. RA will be maximum when this is known as the tail of the UDL and this is the head of the UDL. This is the tail of the UDL and this is the head of the UDL. So 5 kilometer is ahead and the tail of the 10 kilonewton is at the A point. Then I will have the maximum area for the RA. If it moves ahead, what will happen? The area will reduce. So for this condition, this is the way I have to find the area of this trapezoid and area of this trapezoid. And then what I will do? I will find the area of this trapezoid, multiply by 10, area of this trapezoid, multiply by 5. That will give me the maximum value of RA for this condition. How to find RB? For RB, what will be the case? The 5 kilonewton head will be at B, its tail is below. Then I will have 10 kilonewton load and then the tail at this point. In this condition, I will be having the maximum value of RB. Now what I will do? How to find the value of RB? The value is simple. Multiply this area by 5, multiply this area by 10. That will give you the value of RB. So let us do it. So what is the value of RA now? RA will be 10 multiply by 1 plus 4 by 6 into 2 by 2 plus 5 into 3 by 6 plus 2 by 6 into 1 by 2. This is the value of RA. If you solve it, what you will get? You will get RA as 18.75 kilonewton. What is the maximum value of RB? It will be 5 into 1 plus 5 by 6 into 1 by 2 plus 10 into 2 by 6 plus 4 by 6 into 2 by 2. Area of this trapezoid is this, multiply by intensity. Area of this trapezoid is this, multiply by intensity. If you solve, what you will get? 9.58. Now if you compare, what you will see? You will see that maximum value of RA is 18.75 under this loading combination, and maximum value of RB will be 9.58 under this loading combination. So friends, this is the basic of influence line. In the next chapter, I will be discussing a very shortcut method and very helpful method for objective, which is Muller-Breslau principle. Thank you friends for watching this video. I hope you learned a lot of things. If you like this video, give a thumbs up and please write a comment for any suggestion which you want to give me. Also, you can WhatsApp me for any query or any doubt which you are facing while watching the video.
Thank you. Enjoy civil engineering.